Welcome to the Everything Building Envelope podcast. On this show, we discuss topics relating to the exterior building envelope, such as waterproofing, glazing, cladding, roofing, and more. You can subscribe to this podcast on iTunes and Stitcher. For previous episodes, show notes, and bonus video content, check out our website, everythingbuildingenvelope.com. Now, here's your host for the Everything Building Envelope podcast, Paul Beers.
So welcome, everyone. Welcome back to Everything Building Envelope podcast. This is Paul Beers. Today we have as our guest Bob Ford with Eastman Chemical Company. Bob, thanks for coming on today.
Well, Paul, thank you for having me. It's a pleasure to talk to you this morning.
You're with the Advanced and Material Interlayers, is that right?
Correct. The AMI group with Eastman Chemical. And basically what that is, Paul, is that's the interlayer division of Eastman. Eastman acquired Solutia, which many of our listeners may recognize as a brand name of PVB back a few years ago. And so we now are owned by our parent company, Eastman, and I'm within the interlayer division.
And of course, the interlayers are for what we're going to be talking about today is laminated glass.
That's correct. Several applications we'll go into. Obviously, our podcast here is more architecturally oriented, so that will be the focus.
Yeah, so when I have, people asking me, customers or lay people or whatever about laminated glass, I always say, hey, it's the stuff that's in your car windshield, basically.
Exactly, exactly.
And then they get it.
No, I was going to say, it's interesting, a lot of the applications we have within the automotive market have actually moved beyond the windshield, and we can touch on that here this morning.
Okay, yeah, that is interesting. So, but before we do all that, why don't you just tell the audience a little bit about who you are and then, a little bit about yourself.
Yeah, so I've been in the glass industry a little over 15 years. I've worked for both the fabricator side of the market with Interpane Glass back in the early 2000s, and most recently with Viracon, where I was their North Florida and Alabama architectural rep about the last 6.5 years. Viracon certainly is one of Eastman's biggest customers, as are Oldcastle and Trulight and other glazing fabricators within the United States. So within Eastman, as I mentioned, I'm in their advanced materials division, and I handle accounts on the East Coast of the United States and Canada, and basically work with the laminators to help them use our products more efficiently and get them into the market.
Great. So let's just jump right into laminated glass. So we talked about this a little bit, but let's just kind of talk about it. Go back, just run through the basics so that the listeners are on the same page with us. So what is laminated glass and how is it made?
So laminated glass is a composite material that consists of 2 or more layers of float glass. They could be various thicknesses, 1/8 inch all the way up to 1/2 inch lights. And then the inner layer acts as the glue or the sandwich in between the layers to form a cohesive unit. So the process basically starts with laying up 2 or more lights of glass with an inner layer in between them. That inner layer can be PVB, it can be ionoplast, or it can be glass-clad polycarbonate. Laid up in between the lights of glass, it is then run through an oven and a nip roller, which heats the glass to about 160 degrees, and then compresses it through the nip roller somewhere between 80 and 110 psi. So once the glass unit comes through the nip and the oven process, it's then placed in an autoclave where it's in there for about 3 hours. There's about an hour of ramp-up time. It's held at a temperature somewhere between 275 and 300 degrees Fahrenheit for about 45 minutes, and then the glass is cooled. And what happens on the other side of that is a piece of glass that has very special properties. The biggest thing being in most of the applications that we're going to discuss is that composite retains glass shards and pieces should the glass be broken.
When we talk about laminated glass, that's not just all this stuff glued together, is it?
Well, the laminated glass that we'll talk about is, if you say glued together, the glass is laminated and then autoclaved together. So yeah, it could be a 9/16 piece of glass. They can be used in an insulated unit. Down here in Florida where I am, the hurricane code requires laminated glass, but the energy code often needs you to have an insulated piece of glass as well. So we can incorporate a laminated unit of glass into an insulated application.
Sounds like there's a lot of versatility. But what I was trying to get at was when you think of taking all these, the inner layer and the two lights of glass, and you go through this process, it's not just like it's adhesively stuck together. I mean, I know I've seen where people try to pull it apart, and it's like all integral together.
That's correct. Yeah, it isn't anything like applying a glue or anything like that, and then it wears out over time or it can be pulled apart. When the glass goes through this process, the inner layer binds with the glass, and basically what you had is a new product. It's a composite product with properties that make it stronger as well as much safer than standard float glass.
So we talked a little bit at the beginning about the applications being automotive and architectural, and I'm interested, and I'm sure the listeners are, about the automotive uses. Just kind of a quick summary, just so we understand where things are there, because a lot of stuff probably crosses over or will cross over into architectural, and then we'll jump in on the architectural side.
Well, it does. A lot of the applications are similar in principle. So as I mentioned on the onset, automotive really began in the windshield. Windshields with gradient bands are still probably our largest volume market. And the way we go to market with that is we'll work with big laminators like Carlex or AGC, who then will sell that product to Ford or BMW or whatever automobile manufacturer there might be. And again, windshield's still volume and important, but even that has changed. A lot of vehicles right now have heads-up displays, and a lot of our newer projects and our most interesting projects are actually within HUD units. And basically what the PVB does is it allows, or rather I should say prevents, a ghosting of the image. Within a heads-up display, there's a small projector which projects various information onto the windshield of the car. And what the HUD does is it basically, the HUD PVB will allow that image to be more sharp for the driver and prevent ghosting along the edges. In other parts of the vehicle, acoustics is one of the biggest growth areas that we see in automotive PVB. For a while, acoustic side lights were kind of a premium product on only the higher end models of cars. Now we're seeing acoustics throughout the offering of automobile manufacturers like Ford, for example. And a lot of that growth, Paul, is really from the fact that, you know, with our cell phones now and being safe, hands-free driving and hands-free communication with your phone is very important. And in order for that to happen, where you're speaking into the cabin of your car and you're listening on the speakers, you need a quieter cabin. So that's where these acoustic products have really helped to make the cabin quieter and to allow hands-free devices to work more effectively.
Yeah, and you know, we talk about crossing over into architectural markets. I know acoustics are getting more, you know, as things urbanize, as areas, you know, we have more people on the planet, acoustics is becoming more and more important in the architectural market as well, which is where laminated glass began. Even before the hurricane markets, they were using it in airports and things like that. So are there any other crossovers from automotive that we're seeing now or that we may see in the future?
Yeah, I think acoustics is probably the biggest one that kind of translates back and forth. If you think of the idea of a windshield, that if something is to hit it from the outside, obviously the driver doesn't want glass flying into their face or the passenger's face. So the fact that the laminated windshield will retain those glass pieces, that thought process, if you will, translates into security as far as bomb blast. It transfers to hurricane applications as far as keeping the building envelope intact and not allowing glass to fly into the building. So I would say the basic technology of the laminated glass is probably the biggest crossover. Getting more specific to that, I would say, yes, acoustics. And that's becoming a growing segment of our market as well. I think something like 90% of the world's population inhabits 10% of the land. So that automatically is going to bring us toward people in closer proximity together. And though we love our fellow man, we sometimes like a little bit of privacy as well. And as you mentioned, in highly urbanized areas, high-rise buildings, the use of acoustic glazing is more important because it does provide more occupant comfort, and it also increases the sellable cost of buildings and rental spaces. If these buildings have better acoustic performance, it's just a more pleasant place to live, and the owners can get more money for that.
I've got a future guest coming up that's going to be talking about retrofitting hotels, and one of the big drivers for them is the acoustics. And that, like, they did a job, I know they were telling me about in New York City, where they retrofitted the windows with laminated glass, and it made a huge difference for them. And for the property, it was, they could get a return on their investment just because they had better rooms and they could basically charge more money for them. So
that's correct. And I think the same design thought goes into hotels that are located in or near airports. Obviously, with jets taking off day and night, you typically see some really aggressive acoustic applications there. And within the acoustics, the way PVB works is it basically breaks up the sound wave. Glass itself is fairly rigid, so that rigid medium is going to transfer that sound wave pretty cleanly. The PVB is a softer material than the glass, so it disrupts that wave, provides dampening, and that's what is where a lot of the benefit of laminated glass comes from. Is it's not only a thicker makeup and a bigger barrier to get through when you combine two pieces of glass versus one, but you also have that dampening effect as well.
So let's run through the list of the architectural uses for laminated glass, why they're used for various different effects, and then we'll go back and visit each one and talk about that a little bit more. So what's the big list of the reasons to use laminated glass?
Well, we like to, within our company in the industry, we like to refer to them as the 6 S's. And that would be security, safety, sound, solar, storm, and style. With a lot of the low E coatings out there that a lot of our fabricators produce and use, solar is probably a little bit lower on that list because, frankly, low E coatings do a much more efficient job of controlling solar heat gain coefficient or solar heat gain. However, on the security side, that's probably one of the most, unfortunately, growing trends right now as far as bomb blast goes and forced entry. But safety, also very important too. Safety is probably the most generic usage. When we're in a building and we're talking about safety glass on the interior, our ANSI Z91 standard allows us to use just regular tempered glass so that if that glass breaks, it will break in very small pieces and won't seriously hurt anybody. But laminated glass also qualifies as a safety glazing. And again, like many things we'll talk about today, the ability of the inner layer to retain the pieces of broken glass make it ideal for a safety application.
The 6 S's, what I was just thinking about when you were going through them is, let's say you pick one of them, let's just say safety, you get the other 5 S's along with that in some degree on every single application, but do you not? Well, maybe not storm because that's designed specifically for that, but you get a lot, if not all, the other S's every time you use laminated glass. Do you not?
That's a great point, Paul. You're absolutely right. So let's talk about, as an example, one of the most rudimentary makeups that we'll have for a laminated glass unit. So 2 pieces of 1/4-inch glass with a 60 gauge PVB inner layer. And that product is fairly typical for both safety applications, as I mentioned earlier, interior partitions. It can be used for handrails. From a blast standpoint, 060 PVB probably covers the majority of blast requirements for courthouses and airports and other buildings like that. Obviously, there are some specialty buildings like embassies that have higher degrees of blast requirements to them. But if you have a piece of 060 PVB in your glass, you have basically what's in, I would argue, 70% of the blast application out there, which is just 060 PVB. As far as sound goes, 060 PVB will provide a very good improvement in STC or sound transmission class when compared to, say, quarter-inch float glass. And then finally with style, when I refer to style, I sometimes speak about the colors that are available within the PVB family. Most of us who deal with float glass every day know that if we're buying float glass, we're kind of limited to greens and blues and grays. Most of the major float manufacturers out there, even their specialty products, Guardian's Crystal Gray or PPG Solar Blue, are basically in that blue-green-gray family. Within Saflex PVB interlayers, we have reds and yellows, and which can be combined over 10,000 different colors available to provide a myriad of colors, oranges and lime green and bright reds and different shades of blue that typically aren't offered in float glass colors. So when we speak about style, that's kind of what I refer to as color. And again, all of those can be combined with our standard clear PVBs to build up makeup that would be appropriate for a hurricane application.
We have a lot of architects in our audience, I know, and this color discussion, I'm sure, is going to excite and interest them a lot because it can take you out of the ho-hum, as you say, blue, green, gray spectrum and pretty much give you anything you want. Is that true? Yeah, it really is. The different base colors that we have really allow you to mix and match. And we have a website, vanceva.com, that your audience can visit, and you can see the various base colors that are available. We have earth tones as well as more vibrant colors. And by putting up to 4 layers of these colors together, you can literally create thousands and thousands of different shades. Add to that, we also have products that provide opacity, or I should say interlayers that provide some opacity to glass. So if you have an area where you need privacy, you still want to get some natural light in through the window, but you want to have an obscured view. Our cool white and Arctic snow interlayers, for example, will allow you to, I guess, diffuse the light is the best description, and they can also be combined with color. So you really have quite a few options if you're an architect to go beyond the standard palette of our greens and grays and blues that you find in float glass. Really exciting. One thing I want to just jump back on that I had thought about when we were talking before was you mentioned the solar, that the low-E coatings do such a good job these days. And you can have low-E coatings in a laminated glass unit, correct? Yes, that is correct. Most of the time, and if we're talking for the majority of the country that's using, from the hurricane standpoint, you are required to use insulated glass. So the basic makeup would be your quarter-inch outboard light with your low-E coating on the number 2 surface that's up next to the airspace. You then have your half-inch airspace and then your laminated unit to the inside. However, Paul, there are also applications where we want to use a 9/16 light of glass with a low-E coating and an interlayer. And in those cases, yes, PVB interlayers can be put right up against many of the low-E coatings that are offered in the market from manufacturers like Guardian, Viracon, or PPG. Yeah, so not everything always works, but a lot of it does, and you would, so architect or specifier would work with these manufacturers to find out exactly what they offer in that regard, correct? That's correct. Yeah, it would, again, depending on the performance required in your building, as far as U value goes or solar heat gain, and the colors that you want, because as we know, our low-E coatings will impart a color. So we often have a little caveat that if an architect wants a red accent piece or a yellow accent piece, make sure they get that sample with the low-E coating in place. Because as you know, a lot of our low-E coatings that are more popular today, particularly the triple silver coatings, lend a little bit of a green hue to the glass. And that's where, we want to have a sample or a mock-up done before so the architect knows exactly what they're getting. And Paul, that kind of segues me into another area that, speaking of that green hue to the glass, I know a lot of our audience are trying to find coating and glazing solutions to kind of get rid of that green. So a lot of low iron glass is being used in the market today.
And we actually have a structural product that is intended for use with low iron glass that goes more toward a slightly blue cast rather than a green cast, and looks really, really nice when using low iron substrate.
And low iron, just so everybody, we're all on the same page here. Low iron is like super clear glass. Would that be the right?
Correct.
Way?
Correct. You might hear the term ultra clear, and basically the process is that it's further refined from standard clear glass, where more of the iron is removed. It's the iron in the glass, particularly when it's heat treated, that kind of gives us that greenish hue. So when we pull more iron out of the float batch, we can get a low iron product. And all of the major float manufacturers out there do offer a low iron product. You may have heard of PPG's product is Starfire, for example. So different manufacturers have their different low iron substrates in the market.
Now, I just want to throw this out there, not to be a downer, but it is more expensive also.
It is kind of that you get what you pay for, and yes. So low iron glass typically will add if you're using two units of it, or two pieces rather, saying a typical 1-inch makeup. You're going to be looking at somewhere around $1 to $1.25 a square foot premium for each of those lights of glass.
And I have to say, so I've worked on a lot of projects with GCI consultants where where the architects have looked at low iron, and in the past they've been budget busters. They have a budget, they want the low iron glass, and then they get the prices and they can't afford it. But it sounds like the delta has come down a lot. If it's only $1 or $1.50 a square foot, it used to be a lot more than that.
Yeah, Paul, actually, I think as I'm looking, I think I actually misspoke there. I want to say that delta is closer to $2 to $2.25. The other thing I was going to circle back to here when we're talking about laminated glass and in a safety application is heat soaking and being able to prevent nickel sulfide. And the heat soaking aspect of it is more the $1 to $1.25 a foot. You are correct, and I did misspeak that the low iron glasses are typically $2 to $2.25 a foot premium, based on a 1/4-inch substrate. So that was my mistake.
No, that's fine. Even that has come down from, I think, what it used to be. So I think there's more possibilities out there to maybe use that. And I know a lot of architects like that, not having that kind of that color influence that they're not looking for. So that's good information.
And especially if you're looking at, you look at the cost of the entire laminated unit. I mean, a piece of 1 5/16 laminated glass, depending on the interlayer and the low E coatings in the substrate, it's maybe anywhere from $20 to $25 a square foot. So if you look at it from that aspect, the delta for the low iron is not quite as big a jump as far as the percentage of the whole unit's concerned.
That's right. So let's talk about security a little bit more, blast and forced entry. And the blast thing, unfortunately, has become a lot more prominent over the years with the world events, I guess I'd call it, being what they are. The forced entry, I don't think laminated glass gets enough credit for how it performs in that regard. And if you just think about it, like a storefront, a shop, the thing in the past you would always have would be a tempered glass unit, and this is a mischaracterization, but I think everybody gets it. Tempered glass I describe as the glass that breaks into 1 million pieces. So if somebody breaks the glass, it's basically on the ground and there's a big hole in the building. And laminated glass, what happens there?
Well, that's an excellent point. So, and this is something that I think a lot of, like my folks, for example, about 2 years ago they lived down in Fort Myers, so they had hurricane glass windows installed in their home. I think they were just thinking, we'll be safer in a storm, but as a secondary benefit of it is absolutely the prevention of forced entry. To go through a piece of tempered glass with a blunt object is fairly easy to do. I mean, tempered glass is, as we know, is twice as strong as heat strengthened glass, which is twice as strong as regular float glass as far as blunt impact. But you can break it fairly easily with a bat or some other implement. Laminated glass, on the other hand, you can go at that for 20, 30 minutes, and you're not going to make any kind of sizable hole in it. And the other thing is that, in most areas where this glass is located, in residential areas, someone banging away at your sliding glass door with a piece of laminated glass is going to draw a lot of attention. So as a secondary kind of passive benefit, that security and safety from force entry standpoint is one of the very little thought of features of it, but absolutely is one of its strongest attributes.
Yeah, and I always said, because we were back in when the hurricane market was developing, we were talking about the other benefits of glass, and basically what was being said back then was, if you have a I guess we call it an opportunistic thief who's going to try and throw a brick through the window or hit it with something, they're going to get tired and go somewhere else because it's just not going to go well for them.
Correct, and particularly in Florida, where you have a lot of part-time residents down here, and a lot of houses that are basically, no one's living in them for several months out of the year. Those might possibly be a target for some thieves. But again, the forced entry resistance of even regular 060 PVD, if most people are having laminated glass in their 1 or 2 story homes, they have likely 090 PVD or an even stronger interlayer. Unless you have really specialized cutting tools and saws and things like that, the average opportunistic thief, as you say, is not going to be able to make any kind of entry through a window like that.
So people are thinking, well, what about if there's a fire? How does the fire department deal with that? And they do have those sophisticated tools you just referenced, correct?
They do. Yeah, you can. I mean, the glass, obviously, like anything else, does have its limitations. I mean, for a thief with a crowbar or a baseball bat or a brick or a rock, yeah, he's not going to have any luck getting through it. Firemen, however, they have special equipment which basically allows them to saw through the glass, much like they would go through any other kind of wall, and create an opportunity to get in or out of the structure. So, from a firefighting standpoint, they all carry that type of equipment on board so they can get through that laminated glass fairly quickly. The average thief doesn't have all that in the trunk of his car.
Yeah, no. My hope is that we don't have any thieves listening to the podcast. So, but another thing the fire department can do is they can chop through it with their high-tech axes as well.
Correct.
The thing with the security application, this is going to segue us into talking about storm as well, is that it provides passive protection. And maybe you could talk a little bit about that, because that's a really big deal as well.
Yeah, so again, one of the nice things about laminated glass is that it's always there 24 hours a day, 7 days a week, 365 days a year. Particularly for a storm application, the alternative products as far as opening protection may include, boarding up your house with plywood, putting up hurricane shutters, things like that. But those do have their drawbacks. First of all, is that if you're boarding up your house for the winter or the summer rather to go back north, it's pretty obvious to people looking at your house from the outside that you're not home. The other aspect is that during the difficulty of storage and putting up those shutters every time a storm comes in can be a bit difficult, particularly for some of our older population that doesn't want to be up on a ladder or pulling these heavy pieces of metal or vinyl or other materials out of their garage. So laminated glass is always in place. It's always there working, and it's just a very logical solution. Particularly, Florida has a lot of retired folks down here, and it gives them good peace of mind that their home is protected from a variety of threats.
So I live in Palm Beach Gardens, Florida, and I've had this house that I'm in now for 10 or 12 years. It was built to the new code, and it was provided with removable storm panels, which work very well. But I have to tell you, every time a storm comes, it's a major undertaking to get them out of the garage and get them set up on the house. And if you hire somebody to do it, they're going to charge you like $1,000 or more to do it. And it's a major hassle. So you start thinking to yourself as the storm's approaching, is it going to hit? Should I do it? Shouldn't I do it? So last year, I decided to put hurricane impact windows in throughout the house with laminated glass. And, it wasn't inexpensive, but we did it and got rid of all the shutters, which was great. And so this year, Hurricane Matthew was approaching the east coast of of Florida, and it was a big deal. They thought it was going to hit West Palm Beach, and ultimately it didn't. But I was on vacation in Morocco hiking when all this was going on. So, obviously I'm concerned. I didn't have a lot of connectivity. I was texting my son and whatnot. But the great news for me was we were good. All we had to do was make sure the doors and windows were closed and locked, and we were ready for it. And I have to tell you, the difference, the peace of mind, and the confidence that it gives you to have that passive protection all the time, and it's good for breaking and entering and whatnot. It really makes a lot of sense if you live in an area that needs something like that.
You're absolutely right. I know when the storm is coming like that, having lived in Florida since the late 90s, I've seen a lot of hurricane reports on the news, and when a storm is coming your way, there's a lot of other things to do. Having a plan if you need to evacuate for loved ones and pets, if you're going to stay, stocking up on your water and your food and all those things. So there's a lot of life gets really busy when the storm comes in, and if you don't have to put up hurricane shutters, that's one less thing to worry about. I know I can also offer a kind of a personal story here. Before my folks down south had gotten their hurricane windows in, they had shutters up. So when my folks go north, I came down to help my father remove them, and he had the old metal panels that screw in, which work very well. They also tend to be very heavy at times and sometimes a little clumsy to handle. I ended up dropping one of those on my foot. So about 30 minutes later and 14 stitches later, I have a nice permanent reminder on my right foot of the benefits of laminated glass versus hurricane shutters. So definitely and really a lot of the products are now become so much more affordable as far as windows go. And I think that anyone who either is a part-time resident or, let's face it, a lot of us travel for our jobs. And if we have our loved ones at home, we might not always be able to get down there to put up those shutters. So having laminated glass is absolutely good peace of mind.
In 2004, I was in Seattle doing water testing on some hotel projects that were involved. It was an expert witness assignment. And I had my son with me at the time. He was helping out. And I remember we went and paid a lot of money for a plane ticket, took the red eye home, which is not part of my normal DNA, and flew all the way back to Florida so we could put our shutters up. And it's insanity, basically. But the plane from Seattle to Atlanta was loaded with people going back to Florida for the very same reason. It's really interesting.
Yeah, it's as I don't know, Paul, I'm in my mid-40s, and I really don't want to find any reason to get on a ladder if I can help it. Maybe to put up Christmas lights, but that's about it. But plus handling those panels and the weight of them, it's just laminated glass is a much simpler solution. And is there more of an investment up front? Absolutely. But I think all the benefits that it provides just really make it a good investment.
And then on the business side of things, you have people that may be responsible for putting shutters up. If you have shutters on your facility, have families at home, you have the same all the same worries we just talked about. So it makes maybe even more sense in commercial and multifamily applications, not to mention when you get up in the air above the first floor, to have the passive protection, so that's just one less thing to deal with, because these things sneak up on you. I mean, I was in Morocco clueless, and all of a sudden there's a hurricane about to wipe out South Florida, and I wouldn't have been ready for it. So it really, it's compelling, I think.
And the thing that they can change their track so quickly and their intensity so quickly. I remember when Hurricane Wilma came through South Florida back a few years ago, as it was kind of off the coast, it really didn't look like anything that much. And then all of a sudden, it just ramped up into a pretty damaging storm. So yeah, hurricanes were very good at getting better at predicting where they're going to go and how strong they're going to be. But there's still a lot of randomness out there in chance. So better to be protected. And again, laminated glass is one less thing to worry about when that time comes.
That's right. So for hurricane windows and doors and commercial buildings, glazing systems, what has to happen to actually become a hurricane window for a product to actually be a hurricane? And they use, by the way, hurricane proof. I hear hurricane proof windows, and that's not a good term. And in fact, Will Smith, who works for GCI Consultants, just wrote a little blog article for us last week talking about the misnomers that people need to understand, even with the hurricane windows, that they provide protection, they keep the hurricane out, but that doesn't mean that they're shatterproof or anything like that. But let's just talk about what does it take to be called a hurricane, or to have a rating for hurricanes or windborne debris with a window or glazing system.
So it basically is two components. So we can talk about hurricane-resistant glass, I think is the better term. And like you mentioned, Paul, hurricane-proof indicates that the glass won't break. I've had, architects have asked me before, well, if it breaks during the hurricane, then we have to replace it. I said, well, yes, you'll have to replace that window, but it's better than replacing your entire building. So when we're testing, we're basically looking at the framing system. Now, that could be, most of my life was spent in the commercial segment, so that could be a curtain wall, that could be a storefront, that could be a fixed opening, or it could be a residential window. So when we talk about the testing, we need the framing portion and then the glazing infill that goes in it. And basically, the main part of the glazing infill is the laminate, or the laminate interlayer. As the testing goes, glass, if it's annealed, heat strengthened, or fully tempered, it's not necessarily manufacturer specific. You could be getting your glass from Cardinal or Guardian or Viracon or Oldcastle, Trulight, whoever. It's the interlayer that has to be tested with a specific framing system. So what they'll do is they'll build a mock-up of this, and it's also going to be size dependent. So you'll have a given size. I know in the commercial size of things, most people test up to about a 40 square foot piece of glass. So let's say we have our 5x8 test specimen. It's either going to be insulated laminated or just laminated glass. And there's two different tests, Paul, that we do. The first one is called large missile, and that's meant for any glazing that's from ground level to 30 feet in the air. And this is typically a 90 gauge PVB, or it could be a specialty higher performing interlayer, an ionoplast material, or a composite PVB. And basically during the test, it's comprised of two components. The first is an impact portion, where they fire a 9-pound piece of 2x4 lumber at 50 feet per second, which is about 34 miles an hour. And they impact the glass with that. And then the second test is the cycling. And that's the basically to replicate hurricane winds that could last, 4, 5, 6 hours as the storm moves through your area. And that requires positive and negative cycling of 4,500 cycles each at varying degrees of the test pressure. And basically that impact and pressure test, if the glass makes it through that, it will be determined to have passed as a hurricane assembly. And so, again, we have to be cautious of not just putting any piece of laminated glass into any framing system. That piece of glass, being the interlayer makeup, must be tested specifically with that given framing system.
That's a great point, too. The magic glass doesn't just make it into a hurricane window. It's got to go through this design and testing process, and then it's actually got to be put into a product approval system. State of Florida would be one, and I know Miami-Dade County was the first one, and still probably has a leadership position there as well. So people often ask me, I'm looking at getting new windows for my house or for my building. What do I do? Well, the first thing you start with is getting Florida Building Code or Miami-Dade product approval listing and make sure that it's gone through all its testing and make sure that it meets the required wind loads for your project.
That's correct. I often have had worked with some architects on retrofits, and they want to see if they can get away. And this typically doesn't happen in Florida because the market's been so developed down here. But hey, we want to remove this existing 1/4-inch glass and put in hurricane glass in the same frame. Well, that will certainly mitigate the potential damage, yet it would not be considered a hurricane-resistant system. Again, that word system means glass tested with a specific framing system.
The other thing I was thinking about when you're talking about the hurricane glass, what about tornadoes? I know there's not a certification program, but I've often thought, well, not thought, I know this, just it's instinctive, that you see these we're getting into tornado season, well, actually it's in springtime, but it's coming up. And every year there's these horrible tragedies where towns get hit. I remember Tuscaloosa, Alabama was one, and I'm trying to think, the other was, I think, Kansas. And you had like hospitals that were badly damaged. And I've wondered why, like if you have a hospital in Tornado Alley, why wouldn't you put in a hurricane type of window, which would give you a much better chance of surviving, whether it's rated or not? Have you seen any projects where that's been done?
Yeah, well, we have something down here. I mentioned the different large missile impact. We also have something down here in Florida called essential facilities. And those are what they refer to as level E glass. And as I mentioned, the standard large missile test fires a 9-pound 2x4 at 50 feet per second. With the level E, that 2x4 is fired at 80 feet per second, or about 55 miles an hour. And basically what that requires, Paul, is a hardier inner layer to handle that impact. Now, if you're going from that to tornado, there's a FEMA standard out there that I think they want the missile to be fired, the 2x4, at something like 100 miles an hour. And that is an incredibly difficult test to pass. We have had worked with some of our partners to try to create double insulated makeups, basically creating almost like bullet resistant glass to be able to resist something like that, like a 9-pound 2x4 at 100 miles an hour. As far as those buildings that are in Tornado Alley are subject to that, if you get the right tornado hitting you, unfortunately, there's probably not much that glass, if you got talking a 4 or 5 tornado, there's not really a whole lot of building material out there that can withstand that. That said, laminated glass would go a long way to mitigating some of that damage. Again, the idea of maintaining and keeping those broken glass pieces in place, adhere to the inner layer, and try to protect the building envelope would certainly be a benefit in a lot of cases where hospitals and first responders and folks like that, where their buildings are subject to a storm like that.
Yeah, and I've just thought that the hurricane window probably works in a lot of other areas. It's not a fail-safe, but certainly a epic improvement over not doing anything.
Absolutely, correct. And plus, again, a lot of the other benefits we talked about from laminated glass, particularly acoustics, in a lot of hospital settings, that's an added benefit. And from a design standpoint, particularly a lot of the children's hospitals that we've seen that are going up, architects are often using very bright colored windows interspersed amongst the curtain wall. And again, you can accomplish all of those things with laminated glass.
So this segues into my closing question, which is why, so for the architects and owners that are listening to the Everything Building Envelope podcast, why should they use laminated glass?
Well, I just think it provides so many different benefits. And again, depending on the application you're talking about, but basically it's an enhancement over standard float glass. Again, from a color standpoint, your palette of colors is completely opened up to you. As far as from a security standpoint, if you're designing for hurricane and you've got 90 gauge PVB in your building, guess what? You've probably got serious blast protection already in place as well as very good acoustics, as well as prevention of forced entry. So I think this one product just has so many attributes about it when applied to the architectural market that, laminated glass is more expensive than regular glass. I mean, if you're comparing a 1-inch insulated unit to an 1 5/16 insulated laminating unit, you're talking several dollars a square foot more. However, all these other benefits that come along with it, just give you a really good bang for your buck as a designer. And I think we'll see this trend continue for the projects that we see on the horizon.
It's a very, very high performing glass system, basically.
Yes.
So, Bob, thanks so much for coming on. It was really interesting. It was insightful. It was thought-provoking. I thought it was great, and it's really good to talk about this and let the listeners, which they probably know some or a lot of this stuff, but to really be able to hear the whole picture and give them something to think about going forward.
Well, Paul, I appreciate you having me, and I did want to thank you for one thing, that the fact that we're recording this on November the 7th, you didn't ask me any political questions, so I thank you for that. I was waiting for one of those, though, and the only thing I was going to add was that something both sides of the aisle can kind of agree on here is that actually Saflex interlayers are used to protect our nation's most prized charters of freedom, that being the Declaration of Independence, the U.S. Constitution, and the Bill of Rights. All of those, if you go to the National Archive, you're going to view them beneath layers of Saflex laminated glass. So a lot of applications perhaps you don't think of every day.
Good stuff. So thank you, everyone, for listening to the Everything Building Envelope podcast. And this is Paul Beers. Till next time, so long.
Thanks for joining us today. Please subscribe to this podcast on iTunes or Stitcher. For more information on the Everything Building Envelope, previous episodes, show notes, bonus video content, and much more, check out our website, everythingbuildingenvelope.com.